Welcome, my dear students and the real GATE aspirants, to this simplified video presentation on preparation strategy for GATE Electrical Engineering EE. As a team, we are subject experts from ACE Engineering Academy. Together, we would like to talk deep into the strategy for cracking GATE in very first attempt of electrical engineering branch. Now let us first define what is quality and what you need, that is perfection, to achieve such quality, as GATE is a very good quality fundamental knowledge exam on technology in India. Now quality is never an accident, it is always the result of high intention, sincere effort, intelligent direction and skillful execution, as it represents the wise choice of many alternatives. So GATE is a very good quality fundamental technical exam in India, and to achieve this we require perfection. What it means? Perfection is the action or process of improving something until it is faultless. So my simple idea to start this presentation is to achieve such quality exam and be successful in it. Let us also be perfect. Now the agenda for this slideshow is, we have a strategy especially for electrical engineering branch. We will do result and mark analysis. We have in detail subject analysis by our team of subject experts, and then we will also argue and communicate about how to answer certain model questions and then recommended material and books. And then I will brief out on general suggestions for serious GATE aspirants of electrical engineering branch. Now strategy. Now these are competitive exams. So let us understand what are the steps required to really attempt and crack these competitive exams. In simple, step 1. Understand the difference between university exam and competitive exam pattern. Now I want to just show a slide. Now university exam paper is about making the student learn and study to qualify. Then we have the grading system, CGPA system, percentage we say, first class, distinction. But competitive exam on the other hand is an elimination process. On the other hand, it is to restrict the student because opportunities at that high quality are very limited. So these competitive exams are different from university exams, where university exams are about qualifying the student, but competitive exams are about the restricting the students. Then step 2, understand the pattern of competitive exams. The best resource is refer previous exam papers, and especially GATE, since 30 years we know its quality, so please refer and understand the latest pattern. Then step 3, plan further yourself based on your strength and important subjects. Step 4, try to answer at least one question paper within the given time, and you will have the ability to generalize and understand your capability. Then based on that, take a feedback and do the strategic preparation accordingly in the available time. Now what are the qualities that a GATE aspirant should have? Lot of dedication, of course, and patience to read and write, adaptability to the question, the type and the nature, accountability for the money and time, and of course intelligent, and most importantly not just hard work, it is smart work. Now this GATE exam, I want to just brief out about the standard and the quality of this exam. This examination primarily tests the comprehensive understanding in engineering, technology, architecture and sciences, conducted by IISc and all IITs every year in the month of January, February. The GATE score or rank is used for admission into MTech, ME and also PhD in IITs and IIScs, and other universities in India with financial assistance provided by Ministry of Human Resource and Development. The GATE score, as you know, is now also used for PSUs for recruitment of candidates for prestigious jobs, and all PSUs Navaratna we call. So this GATE exam, which is also used for public and private sector undertaking, due to this reason it has got great competition. Now, as per the latest change in pattern for GATE, now we have certain sections like general aptitude and English. That is 1 mark, we have 5 questions, 2 mark questions 5, so total 10 questions for 15 marks. And the next thing is electrical engineering and maths. There are total 1 mark 25 questions and 2 mark 30 questions. So in total 55 questions for 85 marks. Negative marking for multiple choice questions do exist. So it is 1/3 of a mark for 1 mark questions and 2/3 of a mark for 2 marks questions. However, there is no negative marking for numerical type questions. So in general, if you talk about the latest pattern of GATE, total there are 1 mark 30 questions and 2 mark 35 questions. So in total 65 questions which carry 100 marks, and the most important thing is the time duration to achieve this is 3 hours, that is 180 minutes. So you should be well aware about the latest pattern in GATE. These are some of my suggestions. Like, I would like to classify this entire GATE question paper into 3 categories based on the quality of questions and the weightage of the marks to score. Like category 1, let me correct it, aptitude and engineering maths, that is 25% to 30% of total marks. Then these technical subjects I would divide into 2 further categories, like overall category 2, fundamental common subjects, that is 40 to 45% of total marks, and then the core subjects in respected science like electrical engineering, that carries again 25 to 30 marks of total marks. Let us go in detail. Now when it comes to general aptitude, which is common to all papers, which comprises of verbal ability, that is English grammar, sentence completion, verbal analogies, word groups, instructions, critical reasoning and verbal deduction. It also has numerical ability questions, numerical computation, numerical estimation, numerical reasoning and data interpretation, and also engineering maths. Now engineering maths is all about applications. So according to me, this category 1, which is on aptitude and engineering maths, can give you around 25 to 30 marks, maximum 30 marks. So most of the students are very comfortable, so I suggest you to attack this section first while writing exam, which is approximately 30 marks and in 30 minutes. So if you can attack this English and mathematics in the first half an hour, you have every chance to automatically qualify, and you beat almost 80 to 80% of the competition in the first half an hour. Then I categorize the technical subjects into 2 types, common, fundamental subject. But these common subjects generally appear in our first 2 years of our BTech. So they are very fundamental, highly numerical subjects like electrical circuits and fields, control systems, signals and systems, analog electronics, digital electronics and microprocessors, and electrical and electronic measurements. So the nature of these subjects is highly numerical, full of problems, so a lot of practice is required to attempt them, but they are easy and fast and they constitute bulk marks to score. So my suggestion is, after this aptitude and mathematics, please attack these common subjects, and while preparation, first complete and clear these subjects before you go to deep core subjects, because having thorough knowledge on these fundamental common subjects will always ensure you to be more easy way to learn the big things in your life. So concentrate more on these subjects, because they not only give you more marks but in less time. Then I categorize the core subjects, which is the second part of technical subjects, the subjects like electrical machines, power systems and power electronics. Now you know these subjects take generally long time to prepare, and also in exam one require a good theoretical knowledge, principles, concepts, lot of mathematical derivations and applications. But no doubt they are the most important future MTech subjects which have to be at any cost understood by the student, and also these subjects are the most preferred subject in interviews where you apply for technical jobs. Then you know, like GATE is highly numerical and application, and it is now aptitude in nature. So there is nothing much to write in the exam except aptitude skill and logical thinking you develop. And you know 80 to 85% of weightage is for numerical questions, only 20 to 15% of questions are for theoretical, and that too very rare in electrical engineering branch. Then I categorize these technical subject questions into 4 types. Type 1 is recall type. These questions are to be answered from memory of the subject or one line computation and based on definitions. Now second type questions we do encounter in our GATE exam technical subjects are comprehension type. These questions test the candidate's understanding of basics of the field. Then the third category are application based questions, which are very good. He has to apply his fundamental knowledge either through computation or by logical reasoning. And the fourth important category of technical subject questions are analysis and synthesis questions. These can be linked answers questions and common data questions. Now we have total 65 questions in 180 minutes and 100 marks. So you see average 3 minutes, but I think you not even get 3 minutes, as some of the aptitude questions are very easy, but some of the linked questions and 2 marks questions you may take more time. You have to instantly answer in less than 1 minute, and then this extra time you have to allocate to the real quality core technical questions. So time is more important to manage. Then you know, like these days it is online, but still clicking data, everything, it will take some time and difficult to answer all the questions within the time, you know that. So target about 90%. There are certain questions which are maybe due to the topics you did not cover, or you are unable to strike the idea and the concept. So some 10% I think you may take a chance, but target perfectly 90%, which is also good enough to get top rank, because I will discuss about the score and the ranking, which I will tell you in general. So it requires thorough knowledge and practice. Now my suggestion to achieve this good objective standard exam, objective based exam, is to gather standard textbooks and relevant material, make a wide extensive study of theory, read and note down important points on every topic exactly as per GATE syllabus. My suggestion is write short notes where memory plays an important role to remember certain things. Then understand the fundamental concept clearly from root level. For that I suggest you read a simple good textbook once. Then concentrate more on mathematical modeling and equations. So finally GATE is a mathematical paper, so concentrate on mathematical modeling and equations. Then after that, practice previous objective questions of GATE and other PSU exams, including from common branches, the subjects from common branches like networks. If you talk about networks or circuit theory, it is there for EEE, EC and instrumentation, so include that. Then avoid reading irrelevant theory and huge derivations, but remember the mathematical conclusions in them. Then concentrate for more on numerical problems. Then focus on application based problems. Then while attempting, be careful about negative marking. Then sometimes elimination techniques for some questions, like see the all options. If you are good in concept and theory, sometimes reading all the options will give you clarity, and eliminate such options which are not correct will give automatically the correct answer if you are not sure. Then time monitoring periodically is very essential. You allocate, like as I told Nasser, first half an hour you allocate for aptitude and maths, then you come for technical subjects. So you should monitor and allocate time periodically and check this. Now I want to give some basic idea about the history of GATE exam. Like in electrical engineering, if you look at into last 4 years, 2018, 17, 16 and 15, now these are the cutoff marks of the students. Like in general category in 2018, this year, 29.1, this is relatively high, and OBC 26.1, and SC, ST and physically handicapped, it is 19.4. And if you go to 2017, 2016 and 15, you can observe the typical cutoff marks for general category, OBC and SC, ST and physically handicapped students. So generally I would take an average of last 20 years, around 25 marks in general are the cutoff for general category, and 22 marks for OBC, and around 16 to 18 marks is for SC, ST and physically handicapped. Then if you also look at all India first rank marks in EEE electrical engineering, these are such students who achieved that great milestone, and you see at the data, like in 2018 a student who got first rank did achieve 94 marks, that was fantastic. But otherwise you see the average, and 2017, 16 and 15 it is 81.25, 88.39 and 75.96. Of course that depends upon the standard of the paper that is set by these IITs, but in general anything around 85 would be a very good scorecard where you will definitely achieve single digit rank. Now if you look at the analysis about how many students are appearing, how many percentage are qualifying, see 2018 approximately we know that 1,21,380 students appeared for GATE exam. In that 19,421 qualified, approximately 16. But however in 2017, 16 and 2015 if you see, these are the number of students who attempted and appeared, and number of students who qualified and their percentage. So if you carefully look at that, it is ranging from 12 to 16%. Okay. Then let us talk more about electrical engineering branch. Now I made a good slide taking the averages, and I divided all the subjects and I categorized into 3 types as I told. Technical subjects which are fundamental common, and then we talk about the technical core subjects, and then engineering, maths and aptitude. So for the last 4 years I could divide the marks for each subject and their importance. So you can observe the average marks scored in each subject in the red color of the slide. So there are certain subjects which are highly scoring, easy to prepare and fundamental, but there are subjects which require more mathematical detailed analysis, but they are very important. And general aptitude is always for 15 marks. Engineering maths again it ranges from 9 to 14, okay, average is 12. So you should know like which subjects you are weak, which subjects you are strong, where to concentrate more. Based on that you need to have a clear strategy and improve in every subject. Then regarding material, read relevant prescribed textbooks. Now sir, reading textbook habit is very important. In most of your BTech curriculum 4 years, yes, I would expect that you did it. Just take one simple textbook which are Indian authors or sometimes foreign authors, but just read and do solved examples. Then we also suggest our ACE Academy classroom notes from subject experts. ACE Academy classroom published material like volume 1, volume 2, which we do it in the class for the students who join our institute, and also all previous years GATE solved question paper booklet, which includes for the last 30 years or more, and then we have divided it chapter wise and subject wise, which is from our publications, that is Age Engineering publications. Then for common subjects such as controls, networks, signals, analog, digital, measurements, you also practice the GATE question papers from these branches also. And we also suggest to practice more bits from Bits and Bytes edition of AC Engineering publications. And then the most important step is to write lot of exams, practice test. Then based on this test, self-evaluation and feedback can be taken. So this is regarding material, what I suggest. Then, this is the slide showing our ACE Engineering publication. We do collect all the previous papers and detailed solution, and each solution in detailed analysis in multiple methods we do solve and share the knowledge with the students. Then let us talk more subject wise. Now here I will be discussing specific to some subjects, and as our team also will talk about the remaining subjects, and I will be talking about the fundamental subjects, like the first subject, like electrical circuits. We call it electric circuits as per GATE syllabus. Now this is the detailed syllabus of this subject: network graph, Kirchhoff current law, KVL, nodal and mesh analysis, transient response of DC and AC networks, theorems, two-port networks, three-phase and power factor in AC circuits. As you know, this subject is 1 year or 2 semester course. So this is definitely a good subject to start with, and a fundamental rank 1 subject. I say rank 1 because the basics in this subject are so essential for electrical engineers. So this subject is highly numerical. Now I did an analysis on this subject, and I would share the marks division based on the chapters. Now you can see in the slide that these are the typical marks for the last 4 years. But generally now you can be easy to understand that which areas more questions come, which chapters are so important. Like you see network elements, very important, fundamentals, they have more scope to be asked. It discusses about RLC components, their interconnections, waveform analysis, reduction techniques, etc. Graph theory or topology, as you know, every odd year here and there it is coming, but it is a very good chapter. Theorems are no doubt guarantee questions. Then transient response, dynamic response of a circuit, no doubt that a quality question always every time appears from this chapter. Then the bulk of the marks come from AC steady state analysis, and that chapter also includes resonance, magnetic circuits, okay, AC steady state, everything. Then three-phase circuits, no doubt it is very important for electrical engineers, and then two-port networks. I would like to now take up some questions on this subject based on the 4 categories as I told. As I already told, these technical subject questions are into 4 categories. Now first let us take a recall type question. As I told, recall type questions is purely based on the definition and memory and the fundamental knowledge related to a particular topic. Like a sample question I am going to discuss with you. Now in this recall type question, he is asking, a practical current source is usually represented by what? Now the student should have knowledge on what is practical current source. So my explanation is very simple, that practical current source will have a current source in parallel with large resistance, and that resistance will model the leakage current and losses. But if ideal, as we discussed, yes, resistance should be infinity. Now I will take another sample question on comprehensive type or comprehension. Now this question is about capacitors, a very interesting question from GATE 2013. There are 3 capacitors whose values of 10, 5 and 2 microfarad are connected as a network shown with the breakdown voltages. Now these breakdown voltages are the rated voltages, that if these individual capacitors exceed this rating, they will undergo breakdown, that is puncture, we say dielectric breakdown or puncture, flashover, which is very dangerous. Then in this interconnection shown, what is the maximum safe voltage that can be applied to the entire combination, that is entire network, and also correspondingly total charge stored in this system of capacitors. Now first of all, it is a very interesting question which tests the knowledge of a student who know about principle of operation of capacitor, voltage division in a capacitor, charge concept in a capacitor, that is the Ohm's law. So this particular question is definitely testing all the comprehensive knowledge on these capacitors. And moreover, these capacitors are of dissimilar rating. generally in our design we never undergo or consider dissimilar ratings, but is a very interesting question is testing fundamentals by considering dissimilar rated capacitors. Now because they are dissimilar rated, now voltage division is very interesting. Let us look at the solution. Now let us assume that a maximum voltage of Vmax P appeared across this system, that is network, and now you see in this connection, because they are dissimilar rating, I am comparing with each capacitor separately. Now with respect to 10 microfarad capacitor, directly Vmax can be 10 volts, and when it comes to 5 microfarad capacitor, now voltage division in capacitors is inversely proportional to their capacitance, and it can take maximum of 17.5 volts. And with respect to 2 microfarad capacitor, again divide the voltage, Vmax will be 2.8 volts. So in this interconnection, based on their rating, 10 microfarad capacitor can take 10 volts, 5 microfarad capacitor can take only 17.5 volts, and 2 microfarad capacitor can take only 2.8 volts. Now because they are dissimilar rating, with respect to them, these are the maximum allowed voltages. But altogether, now that is very interesting, now altogether he is asking what is the maximum safe voltage. Now the maximum safe voltage for the entire connection is the minimum value, because we know in an interconnected system like a chain, you take an example of a chain, in an interconnected system like a chain, the strength of the chain is the strength of the weakest link in it. So the weak capacitor will decide the overall rating of the system. So my final answer is only 2.8 volts. Now when you give this maximum safe value of voltage, that is 2.8, then the maximum storage charge from Ohm's law, Q equal to CV, we do get 32 microcoulomb. Now let me take another category question in my subject, that is networks, that is sample question 3. It is application type. Now this is a very good question on application. Now this question tests the thorough knowledge of a student on dynamic behavior of circuit, which is transient operation, and also a diode, which is a unilateral device, to a pure LC circuit. And this application comes from power electronics, which is an important circuit we do study on commutation process of our power electronic devices, especially thyristor. So this concept do appear there. So this is a very good question linking circuit theory transient to power electronic commutation circuit. Of course these days commutation techniques have improved a lot, but this is one of the classical way to commutate a conducting thyristor in power electronics. Now see this question, he said that the switch is closed at t equal to 0 with no initial condition on inductor as well as capacitor, but is asking what is the final voltage across capacitor when a DC 100 volts is applied across it. Chalo, in that regard, now this question we can also solve in time domain as well as in Laplace domain. Now the student should be matured enough. If you do time domain by taking initial condition, writing equation, differential equation, solving, taking integral constant, that is a lengthy process. Now the student should have, this is an application, and what is the easy way to do? Yes, my suggestion is the easy way to do is in frequency domain, that is Laplace transform. So now I will consider this circuit and I am just suggesting this solution, see how simple it becomes in Laplace. But in time domain it will take a lot of time. Now let us first write the S domain equivalent of the circuit without any initial condition, and I am writing a KVL. From that I got the expression for voltage across capacitor in frequency domain. Then I do inverse Laplace transform. After taking partial fraction, I got the expression in time domain. But we know because this circuit has a diode, we know diode conducts only for positive cycle, that is as long as the current is going in positive direction from anode to cathode. So the circuit conduction time omega c, that is omega, which is Tc pi by omega. So if you consider this as a tank circuit neglecting diode, you know in tank circuit the frequency of oscillations will be 1 by root LC. So now if you apply this circuit conduction time where the diode conducts only for half cycle, then the final voltage across capacitor is 200 volts. So the very interesting question, that at the source we are giving only 100 volts DC and suddenly switching it, but the final steady state voltage what capacitor will achieve is 200 volts. That is very interesting. You know, the stored energy in the inductor also will be now stored in the capacitor in electrostatic form. So the overall voltage is 200 volts, which is very easy in frequency domain. Now I will take another sample question. This is another type called analysis type. Now this question is analysis type, and I took this from AC steady state phasor diagrams, a very interesting question. That there are 3 voltmeter readings in the circuit. One is supply voltage, one is a voltage across resistor, one is the load voltage, and now he is asking us to determine the load power factor. Now this circuit require a lot of analysis through phasors. So this is another category of question called analysis type. Now in this type question, the student should have thorough mathematical knowledge of how to understand, because the elemental values are not given, but phasor diagram can help us. So that phasor analysis is required. So let us go to the solution. Now I am first drawing the phasor diagram. Because it is a series circuit, I took current as reference and then plotted the voltage across resistor and the voltage across entire load, as well as the total supply voltage, which is the KVL, phasor sum of V2 and V3. Then we know there are 2 individual components, V2 and V3 we know, and the total resultant also we know. But he is asking load power factor. Load power factor is the angle between load voltage and load current, that is cosine of angle between load voltage and load current, that is nothing but V3 and I. But because V2 and I are in phase, it is also nothing but the angle between V2 and V3. So we know from phasor diagram that V2 we know, V3 we know, and the resultant also we know. So I use the simple fundamental formula that comes in our physics, like resultant of 2 vectors. Like if you observe that resultant of 2 vectors, that cos of phase angle is our load power factor angle. So this is linking to such basic fundamentals we learn in our intermediate to an engineering application, which is a very interesting question on analysis. Then my suggestion for standard reference books for electrical circuits. There are very good books in the world written by great teachers and authors. Rather than asking you to read all books, which is not possible, one of these good books you can refer. But apart from that, as I told, that we do provide a very unique, simplified material and notes from our institution, but still these are world class books, and my choice specifically is for Fundamentals of Electrical Circuits by Alexander and Sadiku. Like I will take another subject on analog electronics. I want to just share my knowledge out of how to attempt these questions on this subject. Now again, the syllabus of this subject, that is characteristics of diodes, BJT, MOSFET, diode circuits, clipping, clamping applications, rectifiers, amplifiers, biasing, equivalent circuit and frequency response, oscillators and feedback amplifiers, which is very important, op amps, no doubt, it is one of the major area of analog electronics, and characteristics and applications, and then filters, voltage control oscillators and timers. So this is the syllabus mentioned in GATE. Then again, I did my analysis on the marks division on these individual chapters. Now if you look at that, now these are the areas where I divided the entire syllabus into these subsections and chapters, and these are the typical division of marks. Then you can understand that there are some areas where questions come frequently with more marks, and some areas here and there they do appear. So the student should have thorough knowledge in understanding this subject and understand the areas where you have to strengthen more, like especially like op amps, BJT and FET biasing. Okay, these are the major areas, and also diode circuits. Now here I am again going to discuss some sample question. Like look at this question. Now this question I would say it is one of the fundamental question, like is asking in this feedback network shown, if the feedback factor is K, then what is the effect? Now it is of course from GATE 2013, and these are the options. Now if you look at this arrangement of this interconnected network, now it is a feedback network. Now that block above would represent the analog circuit, but the block below is the feedback. But you see clearly at the output side is taking voltage, that means shunt feedback. Now if you connect any element in shunt, the resultant impedance go down, so output impedance decreases, and is connecting this feedback loop path to the input side in series, that is current. So you connect any element, impedance increases. So my answer is definitely input impedance increases but output impedance decreases. So that is how, this is a question where student should answer based on the fundamental knowledge. I would also like to take another question, sample question, which is about op amp. No doubt this is a major area, an important chapter in analog. Now this is talking about a non-inverting op amp amplifier is shown in the figure, then the output voltage is dash. Now this is analysis type question. I would now put this question into analysis type. This requires some mathematical solving. As you know, what are the characteristics of ideal op amp and the concept of virtual ground. Now if I apply Kirchhoff current law at node B, okay, which is of course, and I also applied KCL, that is at node A. Now after applying this KCL at these nodes and substitution, we got the total output voltage as 3/2 sin 100t. So this is a very good analysis question where you have to apply the fundamental knowledge, understand the concept of ideal op amp and virtual ground, and then solve this equation to get the final answer. Then my suggestion for this subject, there are some great books, and of course my first choice goes to Microelectronic Circuits by Smith and Sidra. Then specifically for op amps, this is a very good Indian author book, that is Ramakant and Gaikwad, and there are much specialized books which also talks at design levels in industry, that is Boylsted. So I suggest to take any one of these as reference and do the solved examples in it. Reading entire book is unnecessary, but do the solved examples in it, and based on the weightage and marks and the chapter allocated marks which I did. So another subject, as I told, that digital electronics and microprocessors. Again, this is the detailed syllabus mentioned in GATE exam. Combinational and sequential circuits, multiplexer, demultiplexer, schematic trigger, sample and hold circuits, analog digital conversion and digital to analog conversion, 8085 microprocessor. Yes, that is an important chapter. Its architecture, programming and interface. Now again, I did divide these chapters, and I could also do the average allocation of marks in the recent 4 years. Of course, this 4 years does not give the entire detailed analysis of marks division, but definitely microprocessor, as I know, its average is 2, though in the last 4 years I could not see any question from electrical engineering, but before that its average is 2, so don't underestimate that chapter. But generally you see sequential circuits and combinational circuits are the most important area, then logic gates and Boolean algebra are the easy things to attempt, and analog digital converters as an application. So these are the areas that you should concentrate, and especially microprocessors. Then here I am discussing a sample question. Now this is an application of digital electronics. It looks a simple analog circuits, but please understand, now this is a transistor operating as a switch, so it is a digital question here. Now see this, the logical gate implementation using this circuit shown below, where input voltages V1, V2, where 0 volts stands as digital 0 and 5 volts stands as digital 1, and the output is dash. Now he is asking this acts as what gate. Now you know this comes under combinational logic, and we are talking a practical circuit where transistor is acting like a switch into gate, logical gate. Now simple, you know how transistor work, you bias it and give input at the base, output is collector side, it will conduct. Now if I take V1, V2 as the two basic inputs for these voltage levels 0 volts and 5 volts as 0 and 1, and I am just writing the truth table. You look at this, if both V1 and V2 are 0, both transistors are off, full output will be conducting, so output is 1. But if either of transistors is on, then definitely that path is grounded, output is 0. And of course if both are on also, the output is 0. So this clearly represents NOR gate. So this is a very good question which is testing the basic fundamental knowledge of student into digital application as transistors are operating as a switch from the truth table. And this basic subject like digital electronics, I would suggest these books like Morris Meno. This is a fundamental book where every BTech student is aware of. There are much better books like Modern Digital Electronics by R. Jain, and don't neglect this. I told us microprocessor is a very important chapter, though in the last 4 years we could not get, but in general it is definitely 2 marks, and you know its programming is very important in any industry. So microprocessor architecture, programming and applications with 8085, that is Ramesh Goenkar is my referred book which I suggest to you. Then I would also like to discuss brief about this subject like signals and systems. Now in 2011 this has been included for electrical engineering. Generally in our BTech curriculum this subject we do not study in most of the universities, but at GATE level this is a very important subject and is a common subject to electrical, ECE and instrumentation. Because when you now join industry, though you are from power engineering side or signal side, lot of interfacing and thorough knowledge is required. So signals and systems is another important added subject in GATE where students should have thorough knowledge, and it is a highly mathematical subject, and this is a complete syllabus representation of continuous and discrete time signals, shifting, scaling, linear time invariant, causal systems, Fourier series, sampling theorem, application of Fourier transform, Laplace transform and Z transforms. As you know, these are very important for electrical engineering applications. So though we don't study this in our regular BTech curriculum, but as applications and when you join for research and industry, this is a very important subject. So don't neglect it. Generally the electrical students have a mindset to neglect these electronic side subject, signal side subject, but very important, and let me tell you they are more easy and we can score in less time. Now again I divide this entire subject into these chapters and the recent marks division for the last 4 years. So from that you can easily analyze that Fourier transform, Z transform, see guarantee question, and Laplace we do also get in other subjects, so somewhat less weightage, but still LTI systems, their definitions, sampling techniques, these are all very important. I just gave the average of 4 years, and now I am discussing a simple question there. Now this is a very important question linking the concept of resonance with signals and systems. Now see how good this question is. A symmetrical square wave of 50% duty cycle has an amplitude of plus and minus 15 volts at a time period of 0.4 pi milliseconds. Square wave is applied across series RLC circuit with these values of RLC. The amplitude of the component which is at 5000 radians per second across the capacitor is asking. So the amplitude of 5000 radians per second component of capacitor voltage in volts. So very interesting. Generally in network theory we study AC steady state, that is for sinusoidal excitation. But the given input signal is a periodic signal, but it is a square wave. Now the student should have that knowledge. A square wave talking about voltage across capacitor, and that too a component he is calculating at 5000 radians per second, that means it comes from Fourier series. So that is where signal application is mentioned here. Now just let us discuss the solution here. Now for the supply waveform, if you do Fourier series, that is the expansion we get, that is sigma 4 VDC by n pi sin n omega t. Of course omega he is asking 5000 t, and as it is symmetrical we get only odd harmonics and there is no DC component, and that knowledge a student should have from signals, and this signal application now is linking to networks. Now the fundamental component of waveform, if you take that n is equal to 1 we get this, and with omega is equal to 5000. Now that component is like steady state sinusoidal component, and now at this component frequency of 5000 radians per second, if you substitute the reactances of inductor and capacitor we get it, and at that the phasor current can be calculated with that, and now the voltage across capacitor, Ohm's law, I into XC, which is around 191 volts. So see, this good question is linking multiple subjects where a student should have thorough knowledge on signals. So there are a lot of questions in this pattern where you should have fundamental knowledge from other subjects and application do link with other subjects. So that is why don't neglect, there are so many questions of this pattern, but I am just taking a sample question to show the importance of this subject. Then these are my referred books. Okay, I would suggest you to refer these books like Signals and Systems by Oppenheim and Wilsky, one of the old and great books, and other book is from Heiken, and we also have especially some areas like discrete time systems, Z transforms, etc. by Zimmer. These are very good books, and I suggest you to just do the solved examples rather than reading entire book which is unnecessary and irrelevant. Do the solved examples in these good books, and as I suggested, these are the things I would like to discuss with these basic subjects. Our team further talks about remaining subjects.